Welcome to another episode of The Cloud Show. I am not at home, as you can see. I am here in Belgium at the Cloud Brew Conference, standing in one of the sponsor booths. This is Axis sponsoring this community conference, and we want to give a really good thank you for companies that decide to sponsor community events. Awesome work. Now, I want to talk to another person, another speaker here at the conference. We're going to be talking about metadata in messaging, and whom better to talk about messaging than the star of the show, Clemens Vasters. Hello, Clemens. How are you doing?
Hi, Magnus. Fantastic.
That's great to see you, man. It's
Great
good
to see you.
finally in the same space again. You were saying that it's been a while since we saw each other.
Well,
I don't know.
it's been,
We haven't been to the same events, I guess.
Exactly. Yeah,
Right?
like 3 years or something, or
Too long.
minus pandemic, whatever.
Right, something like that, yeah. But you have a session here at the Cloud Brew Conference
Yes.
talking about, well, as you do, messaging.
Yes.
Yes. But specifically now talking, well, wait, by the way, I think everybody knows who Clemens is, and I'm so excited to talk to Clemens. Tell the audience who you are, Clemens.
I'm the lead architect for the messaging services in the Azure cloud. So our team owns Service Bus, Event Hubs, Event Grid, Stream Analytics, the Azure Relay, and also the Fabric event streams inside of Microsoft Fabric.
So a bunch of messaging stuff,
Yes.
essentially. That's the summary of it.
Yes.
All messaging. All right, cool. So now you said in your session, and I just listened in on his session, that the problem is not in messaging or the infrastructure or any of those things. The challenge remaining is in a different space, in metadata. Please explain.
Yes. So one of the goals we have let me start with, we're building services both in Azure and in Fabric.
Mm-hmm.
And Fabric has a very different target audience from the developer audience that we find in Azure. So the target audience we have for Fabric is data analysts, maybe data engineers, but also end users.
Yeah.
And of course, we can't confront them with all the complexity of building applications or even these pipelines.
Well, they're not developers at heart. They're different kinds of people.
Correct. So we need to be able to make it very easy for them to kind of plug pipelines together. And plugging pipelines together means you need to have some structure, like Lego, right?
Yeah, right.
Where you can go and say, this thing has, this thing fits into this thing, this fits into this thing. Now, with data streams, that is hard because data streams just move bytes.
Yeah, and you were saying very nicely in your talk, which I enjoyed, that we have to agree on what the message structure is.
Correct.
If I'm going to send you a message through a pipeline, and sometime later you're gonna do something with that, we have to first agree what's the format of the data we're actually sending here.
Yeah. So there's two elements of it. There's structure, and then there's encoding.
Right.
And you may want to go and send the data as JSON. You may want to go and send the data as Avro. But then you also need to go and define what the structure of the data is. And very often in practice today, people are just building apps that are just putting some data on the wire without really describing that to everybody else who's collaborating with them.
Yeah.
And that works because right now pipelines, even down to visualizations, are built by just a few people.
Right.
So it's all tribal knowledge, and they all can go and look at the code, but that's something that doesn't scale.
Right. No, it doesn't. And also, if I'm sending my data to some completely different system, someone else, you're not sitting across from me working together with me. You're a different consumer somewhere else.
Correct.
Then I need to still tell you what I intended my data to be like.
Yes. So
right?
The obvious solution to that problem is to it happens at two layers. Mm-hmm. So first, when you're sending a message to someone else, you need to be able to go and declare what is the shape of the data that sits inside that message.
Right. Yep.
And we have mechanisms for this. We have things like JSON schema. We have Avro schemas. We have protobuf.
Okay.
We have all this information. And for encodings like Avro and like protobuf, it's required that you have these schemas because otherwise you can't encode and decode.
Okay.
And for JSON, people mostly think I probably don't need this because the data is self-explanatory,
right?
And it carries the type and the data. Mm-hmm. What they forget is that if the person who sits at the other end of the pipeline is not a developer and is not in their org, but they might be a data analyst or someone else who wants to make sense out of that data, and you have a field that's called temperature.
Right.
That's related to a light bulb.
Right.
What does that mean?
What does it mean? Yeah.
So, well, it could be the temperature of the light in Kelvin.
Yes.
It could be the temperature when you touch the light bulb, right? In Celsius or in Fahrenheit.
Yeah.
You can't know. So
like the field says that it's temperature.
Yes.
But what temperature?
Exactly.
Yeah.
So, and the way how you find that out is by having a schema that has a description in it.
That's right.
It's not easy. It's not rocket science.
No, it's not at all.
Right.
It's not like we haven't done specs before.
For managing these sorts of schemas and messaging, we have schema registries. Those things exist, and they have existed.
So you publish your schema, say, here's my schema.
And then the party that's receiving it can receive it. But those schema registries have been effectively limited, the scope has been limited to like Kafka or the event stream.
Okay.
But they could not really be used by a database or anything else that sits downstream. They could not leverage this.
Okay.
So we need to have an open infrastructure, we need to have an API, we need to have a way to go and talk to that schema registry from all kinds of pieces of infrastructure.
Okay.
In addition to this, when you're sending data through an event stream, you usually don't only send one type of messages. You send 3, 4, 10 different kinds of messages.
Okay.
So you're multiplexing. Mm-hmm. So now it's not one schema, you're actually dealing with 10 schemas.
Okay, yeah.
So how do you distinguish those messages? Well, one way to distinguish them is by having standardized metadata that says this is this kind of message and this is that kind of message.
Sure.
So work we did 4 years, we finished 4 years ago, and since then has been nicely adopted is Cloud Events and CNCF.
Yep.
And Cloud Events gives you effectively a standard way to describe what's in an event, what is the type of the event, what is the context of the event.
Right.
So we're leveraging that to kind of manage demultiplexing and multiplexing of event streams. Mm-hmm. What we saw in the Cloud Events project then is that we needed to have a machine readable version, if you will, of a declaration of which events can be associated with the stream.
Okay.
And that's how we started an effort that was first called Cloud Events Discovery, and it's now called X-Registry. And what X-Registry does is gives you, first of all, an extensible metadata catalog for all kinds of metadata.
Okay.
And then specifically implements 3 metadata registries. One is for endpoints, where you can go and register, I have this endpoint over there that speaks Kafka and has the following characteristics.
Okay.
We have a registry that can handle message definitions or event definitions, where you can, so there's a set of cloud events that have these types, and you can go and take that group and associate that group with a stream. Now you have a contract. Now you can say, I can send 4 events to this stream, and I can expect these 4 events coming out of that stream.
Okay. Yep.
And then there's a schema registry, and the schema registry then basically gives you the detail in the data insight effectively into what's carried inside of these message envelopes.
Right.
So it's 3 registries which follow exactly the same mechanics in terms of interacting with them through the API, and also for the document format, which is also there, which cover different aspects effectively of the metadata problem. And what we have been building or are building, kind of as a preview for the product, but also as open source experimentation field, is tooling that can now go and take that metadata and so from the schemas generate code for data transfer objects.
Okay, that's
in a consistent way.
Yeah.
And then can also go and take a look at these message definitions, basically these interface declarations, and can create full clients.
Wow.
So that you can go and create, let's say, a Kafka producer.
That's great,
and you can say the Kafka producer needs to go and produce these 7 messages.
Okay.
And the send method only takes your business object effectively, your payload object as parameter. Yeah. And then creating the right cloud event with the right attributes, sticking it in the right place with the right encoding into the Kafka producer, all that goop that is mostly repetitive work that's already done, that can already be done by a code generator.
That's so good.
So, yes. So the goal of all of this is effectively to enable less friction allow less friction in the development of these pipelines, because we see massive interest in real-time data feeds.
Of course.
But building them is too hard, so we try to take the friction out. And then ultimately, the vision is that you can define data structures, you can describe data structures,
Yeah.
you can make them known through the catalog to an analyst, even
Okay.
without that necessarily being already a data feed that gives you the data.
Okay, yeah.
The data analyst can then go to their co-pilot
Okay.
and say,
Brilliant.
hey, I would like to have the following visualization for the following speculative data.
Ah, nice. Because the co-pilot can understand the metadata. It can interpret
now it's the metadata. So the co-pilot can now basically figure out iteratively, we're going to go and do a visualization for data that you don't have yet.
Uh-huh.
And then you can basically go and you can finish your visualization. We can use effectively that metadata to also create a little data generator, which goes and creates fake data.
Okay, fair.
Right?
Yep.
And then once you have that, once you're happy with your sketch of the visualization you now have a model effectively of the data stream that you want. You can give that to the developer by ways of just generating an SDK for them and say, you go and give me that data and you feed that to me. So you can enable right-to-left development, as I call it.
That makes sense. Yes, very cool. All right, so that's what you're going towards.
Yeah, so we're effectively what we're trying to do. So in a sense, it is open API for streaming.
Okay,
right?
sure.
That's the simplest way how we can look at it.
Uh-huh.
But it's a very specific metadata model for event streams or for messaging, which is all unidirectional pipelines for data. So there's more weight on the data rather than on the this API interaction.
On the API stuff. Forgot it.
And if I look into the future of that standardization story, once we're done with X registry, which I hope is very soon.
Okay.
At least the 1.0 version.
Yeah.
The next frontier is effectively how do we model these interaction shapes. So if you, for instance, go into financial industry, is now switching to ISO 20022, which is kind of the data exchange standards for them, all in XML.
Yeah, right.
So when you look at the sets, for instance, the messages are exchanged in a cash machine.
Yep.
There's a set of exchanges that's defined between the bank and the cash machine and how that all happens. Yep. That is, it's defined as an activity diagram in UML.
Oh, okay.
In the documents.
Right.
And many people do this as activity diagrams where you can have the swim lanes, and then you have kind of the message flows. This happens there. So I think the next step, better than having an API approach where you have input, output, and you only look at this from one perspective, have a holistic formal description that you can go and then create for these flows. There has been prior art for this in the ITU in the 90s called Z120. Don't look at it. But they had kind of a similar approach. That's kind of where we want to go with it.
All right, very cool.
So big story.
Yeah, it's a huge story, and I think from what I saw, it's really cool to be able to get that stuff generated, like the plumbing code stuff. No matter what I'm going to talk to, which database it's going into, it doesn't matter. All of that is boilerplate and can be generated.
Yes.
And why would anyone ever build that themselves?
And it's when you look at these tools, so one is the X registry CLI tool that's in my repo. The other one is called Advertise.
Sure.
When you look at those tools and when you look at the input metadata and what comes out of it, you see that the input metadata is very minimal. It's not a super complicated set of things that you need to go and define. And then you see how much complexity there needs to be to go and interact with that messaging infrastructure consistently. And that's all stuff that nobody really should write. But it's required to be interoperable, right?
Yes,
so there's a level of complexity that's required for interoperability so that everybody can go and agree on those things. But at the same time, for an application developer, it's too much. So how can we go and bridge that gap and make the application developer not worry about all that stuff too much?
Perfect. Well, great. Thank you for being on the Cloud Show, Clemens.
Thank you for having me.
Absolutely a great explanation of metadata in the messaging world. And audience, see you next time on the Cloud Show.
Fantastic.